So now that we know how to use the zero product property, we can jump into how we can solve quadratic equations by factoring. And I want to start by saying that in order to solve equations by factoring, you need to have zero on one side. So let's look at our first example. We have x squared minus 4x minus 21 equals 0. I like that we have that equals 0. That means that I can try to factor what's on that left-hand side. So there's lots of different ways to factor things. So you need to make sure you go back and review that factoring flow chart and know those steps of what you're supposed to do. Here, I should check for a GCF. There is none. I do have a trinomial. The coefficient up front is 1, so these are those easier trinomials. I need to find two numbers that multiply to negative 21 and add to negative 4. And those two numbers would be negative 7 and 3. So I put those numbers in parentheses. It's x minus 7 times x plus 3 equals 0. And now that it's in factored form, I can use the zero product property and know that my two solutions must be x equals 7 and x equals negative 3. For my next one, we have x squared plus 16x equals negative 64. I don't have 0 on one side. So my first step is to get 0 on one side, and to do that, I can move this negative 64 by adding 64. And I'm going to throw it on the left there. Please note, I'm not actually going to add 16x and 64 together because they're not like terms, but I will get x squared plus 16x plus 64 equals 0. I should check to see if there's a GCF. There is none. And I'm looking at this and I notice that this is a square of a binomial, okay? Or really I'm dealing with a perfect square trinomial, which leads into factoring it into a square of a binomial. Because I see x squared is a perfect square, 64 is a perfect square, so I'm thinking it should be x plus 8 squared. And remember, you should always check it to make sure. We want 2 times the first piece times the second piece to equal 16x. So 2 times x times 8 does indeed equal 16x. So I know that the factored form is x plus 8 squared. So I have x plus 8 squared equals 0, which means there's only going to be one solution in this case, which is negative 8. And in C, I have 7x equals x squared. I don't have 0 on one side. And I have a choice as to where I want to move things. Okay, I could move this x squared to the left, but I'd have to subtract it, which would make it negative. When we factor, we always want that leading coefficient to be positive. If not, we have to factor out a negative. So to me, it makes more sense to take this 7x and move that over to the right-hand side. So I'm going to have 0 equals x squared minus 7x. If you have a choice of where to move things, I tend to move things where the x squared is already there so that we keep that leading coefficient positive. Now I check for a GCF, and there is one. So I have an x I can pull out, which would leave me with x minus 7. Now it's in factored form, and I know that x equals 0 or x equals 7. I do want to note that if you can't factor an equation, such as this one right here, 0 equals x squared minus 2x minus 4, we can't figure out two numbers that will multiply to negative 4 and add to negative 2. It does not mean there is no solution. It does mean there are no rational solutions. There's no solutions that you can write as fractions. You would have to use another method to see if there's any irrational solutions or if there is indeed no solution. And what I did is I threw the graph of the related function on there. This is the graph of y equals x squared minus 2x minus 4. And you can see that it does cross that x-axis, okay? So we do know there's two solutions to this. It's just that they're going to be irrational. And we'll have other ways of solving quadratics that will tell us what those irrational solutions are, but we're not there yet. Okay, the second part of this video, I want to talk about using factoring to solve a real-world problem. Okay, and I will say for these questions, we're going to end up with some larger numbers that we're trying to factor. It is totally okay for you to use a calculator. to figure out what those factors should be that multiply to something and add to something else. Calculator's totally fine with me for this. So we have a museum vault that has an outer steel wall with a uniform width of X. The area of the museum vault ceiling and the outer steel wall is 1,664 square feet. What is the width of the outer steel wall? So in this case, we know the dimensions of that inner section, okay, the vault itself. There's the border of X feet on either side of it. And they're telling us that the whole top area, okay, the ceiling of the vault and that strong border on the outside is this much. Okay, that's going to be different from our next scenario. In this case, we have the whole area. So we need to write an equation that's going to model this scenario. So hopefully you remember that area of a rectangle is length times width. So we need to write expressions for our length times width, multiply them together, and it's going to equal this 1664. So for my width, I guess, width is usually smaller. We have our 20 feet there, but we also have X and another X. So 20 plus X means one of our sides is 20 plus 2X. For the other one, we have it as 40 feet, but we also have an X width here and an X width here. So that one's going to be 40 plus X. In other words, 40 plus 2X. So the length times the width together equals 1664. And now we cannot solve this if it's not set equal to 0. So that's our next goal, is to get this equation set equal to 0. And some people might want to just kind of say, oh, let's subtract 1664 from both sides. The problem is then you would have something that looks like 20 plus 2X times 40 plus 2X. I'm going to end up erasing this, so don't necessarily write this down. Minus 1664 equals 0. And we no longer have a product of two expressions. We can't use that zero product property anymore here. So while we are going to subtract that 1664 to the other side, what we actually want to do is simplify this expression on the left and actually distribute it out. So when we distribute this out, 20 times 40 is going to be 800. 20 times 2X is 40X. 2X times 40 is 80X. And 2X times 2X is 4X squared. Okay, I'm going to simplify that left-hand side. I'm going to rearrange it so it's, in standard form, from highest degree to lowest degree. So that's going to be 4X squared. 40X and 80X is 120X plus 800 equals 1664. And now that I've simplified that left side, now I can move that 1664 over, combine it with the constants that were already over there, and I'm going to end up with 4X squared plus 120X minus 864 equals 0. And our numbers are quite large, but the good news in this case is that 4 is a GCF, so we can actually factor out that 4 to make this a little bit easier to work with. So that'd be X squared plus 30X minus 216 equals 0. Okay, and now this is where it's a little bit annoying because you would have to find two factors of negative 216 that add to 30. And I know because I did this ahead of time and I'm looking at my paper that it's going to be negative 6 and 36. So we wanted factors of 216 that went, and that was negative 6 and 36. So that means it's X minus 6 and X plus 36 equals 0. And now we have equals 0 on one side, we have it factored on the other side. Now we can use that zero product property. That 4 does nothing, there's no variable with it, there's no way that that outside piece is going to be 0, so we can kind of just ignore it. But we do know that X equals 6 and X equals negative 36. But you'll see my note over here that we need to check for answers that don't make sense. A lot of times when we're solving real world quadratic equations, okay, there's going to be an answer that's an extraneous answer. It's an extra answer that you can't actually use. And if we're thinking about what x means, x is the width of that wall. We have this negative 36. You can't have a width of a wall that's a negative number. So in this case, it can't be negative. So that negative 36 actually doesn't count here. And our actual answer is just that the width of the wall must be 6 feet. Okay. And B, we have a picture inside a frame that has an area of 375 square centimeters. What is the width of the frame? So this one's a little bit different because we have those outside dimensions and then the inside area. Whereas the last time we had the inside dimensions and that whole outside area. So that's a little bit different here. And if we know this area, we need to figure out a way to write expressions for that length and that width right here. And to do that, we're going to use the fact that we know this entire width and that there's an x there and an x there that we don't want to include when we're trying to figure out the width of that inside area. So that means we have 20 minus this x and this x, okay, which leaves us with this width. So that must mean that the width of this is 20 minus those two x's. For the other piece, we want to know what is this length. And we know that that's going to be, I guess I should have done on this side because it's numbers over there. Okay, the whole thing is 30. This part is x and this part is x. We want to take those away. So this one is going to be 30 minus those two x's. So this blue part is going to be 20 minus the two x's. This green part is going to be 30 minus two x's. And together that equals 375. And now similar to the last one, we want to simplify that left side. So when we distribute it, we're going to get 600 minus 40x minus 60x plus 4x squared. I'm going to combine my like terms, write it in the correct order. So 4x squared minus 100x, because negative 40 and negative 60, plus 600 equals 375. Now I want this side to be 0. So I'm going to subtract 375 from both sides. Oops. So I get 4x squared minus 100x plus 225 equals 0. And unfortunately, there is no GCF because 2 goes into here and here, but doesn't go into 225. So we can't make these numbers any smaller. So we get to do 4 times 225, which is 900. And we need 2 factors of 900 that add to negative 100. So you play around with the numbers. This one's actually not too bad, even though it does look a little large. It ends up being negative 90 and negative 10. But this is the one where we had that coefficient, so we need to split up that middle term. So we have 4x squared. Remember, it doesn't matter which one you do first. I'll just stick with that 90. So minus 90x minus 10x plus 225 equals 0. And then you factor out the GCF from the first two. So that's 2x times x minus 45. We know the other parenthesis for these must also be x minus 45. And that means, oops, sorry, I totally missed my 2. It should be 2x minus 45. And then we should have a minus 5 here. So our fully factored form is the stuff we pulled out, 2x minus 5 and 2x minus 45. That parenthesis that repeats is our other factor. and we have factored this equation, it's equal to 0. Now we can use the zero product property. For this one, we would get 5/2, which is 2.5. And for the other one, it would be 45/2, which is 22.5. And it does appear that we have two answers because neither of them is negative. However, in this case, looking at this, this picture, okay, if the whole thing is 20 centimeters on this side, 30 centimeters on that side, but I guess really more so the 20 centimeters here, there's no possible way that this X, which is just that little edge of the frame, can be 22.5 centimeters. Okay, that would be bigger than the entire side is, okay, so that can't happen. So this is actually too big. So our only answer in this case is going to be 2.5 centimeters. And that is it.